Good morning. Let's begin. Okay, homework 14 is due on Thursday, and we're going to cover two more ideas that factor into that assignment. The next thing on the horizon after the homework assignment is the project. And so let's take a few minutes to answer the question, what should I be working on right now with the project? This is not the sort of project that will go well if you say, all right, it's the night before the due date, I'm really going to get into this and figure it out. Because I'm going to just see right through that in the rushed research and the poor quality calculations. And since you've had the assignment in your hands so long, it'll really be difficult for me to be generous and lenient on the grading if it feels like something that you've rushed through. So are there any questions or anything that you'd like to ask about since we've got just a couple of minutes so we could discuss the project? I want to encourage you to get as much done. I mean, just finishing it during the break would be such a great idea. Then it's just out. It's just out of the equation entirely, and you don't even have to think about it anymore. Yeah. There's the ordinary costs and the extraordinary sort of like one-time events. Yeah, right.
So like what accuracy do you want?
Mm-hmm.
Of course you want something like
Right, okay. So the question is, how detailed should the accuracy be on the cost estimates? I think that what you should do is you should look at each category of things that you might spend money on, and don't just do an estimate in each of those categories. Actually go and make a summary of what your costs are. So instead of just saying transportation, I'll give myself 1,000 dirhams per month. Don't do that. It wouldn't be enough. But if you say, I plan to live in this certain neighborhood, the company is in another part of town, here's the distance, a taxi 20 times per month would cost. So, I mean, that's detailed, but you could do that calculation in probably 2 minutes by looking up the distance online. So that's just an illustration. So in the case of food, don't just say, I'll give myself 1,500 dirhams every year for food, because that's just, that number's coming from thin air. But if you actually maybe talk to your parents about how much they spend each month on food and divide it by the number of people in the household, or if you did the shopping one time and added it up and figured out how much it costs, or you could go to, just as a starting point, you could go to the CPI, the Consumer Price Index, and see on a percentage basis what people are spending their money on. But I'd caution you about making that the only source of information for any kind of an estimate, because that's talking about just the average of such a wide range of lifestyles that it may not be directly applicable to you.
Can we look at different categories of foods and estimate how much we eat?
Sure. Yeah, if you want to go into more detail than just food overall, then I encourage that, yeah. I mean, overall, like the guiding principle that I'd use is if you spent less than an hour developing your cost estimates, that's a good indication that you haven't given it enough thought. If you spend more than 8 hours, then probably you're working too hard. So somewhere between 1 hour and 8 hours would probably be an appropriate level of effort. What do you mean by each stage?
You need the cash flow, right?
There should be a cash flow diagram, yes.
This cash flow should be like spread on 40 years.
Okay.
Right?
Mm-hmm.
We have costs, we have income, we have, like it should be a net cash flow diagram, right?
It should. It should
At each
include.
stage you want a separate cash flow diagram?
When you say stage, you mean income on what? No.
Income.
No, that's not a good idea. You should put all categories together on one cash flow diagram. Now, you can break it up by year. If you think 40 years is too long, you could do 5 years at a time. But it would be a mistake to have only your costs on one cash flow diagram, only your income on another. It should be a combined.
I tried drawing the cash flow diagram.
Mm-hmm. PowerPoint is a good way to do the cash flow diagram. That's how I usually do it. But really, It's just an illustration, so you don't have to worry about it being, for example, the lines exactly scaled to the costs. Don't sweat too much about that, because where I'm going to go to find out the actual amounts is the Excel table. You know, you should put together a table that has columns like, in one column is your income, in one column is ordinary expenses, another one extraordinary expenses, and then, of course, income minus expenses is savings. So you'd have another one that's savings for that year, and then finally a column that has the net assets. And so, like, what's the balance of your investments? So that's where I'm going to go for the details, and then the cash flow diagram is just to briefly visualize what's happening over time. Mm-hmm. Yeah. Sure. Yeah, because, for example, if your investments, as you get closer to retirement, they say you should get more conservative with your investments. You shouldn't put it into risky stocks anymore. You should start to move the investments into bonds or savings accounts where there's less of a probability that you'll lose money. So you can use different interest rates, or if you know something I don't and you say, you know, in 2035 there's going to be really high inflation, if you want to make some sort of a Nostradamus prediction like that, by all means, I'd love to see how it works out. Yeah. Any other questions about the project? Yes. By looking at inflation in the past. And you don't know exactly what the inflation will be in the future, and I think everyone recognizes that. But if in the Emirates inflation has been between 4 and 6% for the last 10 years, then it would be perfectly reasonable to say in the next 10 years inflation will probably be between 4 and 6%. It's all you can do, right? You don't know the future, and so the only option you have is to extrapolate from the past. Excuse me? Inflation? Of course.
You said CPI, what is taking the average?
No, when I was talking about the CPI, I said don't use the CPI alone for an estimate of what your expenses are going to be. Because remember, the CPI is including the expenses that a laborer faces, the expenses that a multi-billionaire faces. I want to know what you plan to spend money on. And if you want to use it as some guidance to give you maybe one idea, that's fine, but it shouldn't be used alone. Did you have a question, Ali?
I was asked about the inflation.
Mm-hmm. It's hard to predict, and so you need to be prepared for any possible outcome. If inflation is greater, then what that probably will mean is that your investment returns would be greater as well. Because when inflation is high, then savings rates go up as well.
You want this project that, for example, if you already have something going on now, should you include it or should you, it's not like real life?
No, it's real life, yeah. So if you already have 1 million dirhams in your savings account, then the savings count column, or if you already have income, I'd like it to be as realistic as possible, because the whole point of this project isn't for you only to make some wild predictions about the future, but I'm hoping it gets you to think about your own circumstances and realistically why you're here and why you're getting education, so that it can provide an income and the lifestyle over the long term, what that's going to look like. So I'd love for it to be as realistic as possible. What we're covering today is 2 sections from the textbook, cost capacity and factor method. Both of these are really easy. And like I said before, the next homework assignment you're working on, it's also easy. So the complexity level in the course is, we've reached a plateau, and it's just a few extra ideas for the rest of the semester. So I hope that liberates some of your excess mental time to complete the project. A cost estimating relationship, that's a fancy phrase that just means an equation or an approach to predicting the cost. And we've talked about how we can use a cost index to do that, to track changes in expenses over time. What this equation is used for is relating the expense of big things to small things. So what you can see here is that you're trying to predict the cost of some item under condition 2. And condition 2 usually means a different size than the item that you know the cost for in condition 1. So C1 is the price of something that you know in the past, but the two items aren't the same. Q is talking about their capacity. So if you were designing a water network, then Q1 could be talking about the diameter of a pipe and that you know, and Q2 is the diameter of the pipe you're trying to figure out. So it could be related to a tower crane. It could be related to a cement mixer, just anything where size has an effect on the cost. What you can see here is that there is an exponent, and the meaning of the exponent is that sometimes as you get bigger and bigger items, there's a nonlinearity between the size and the cost. And so if x is less than 1, what that means is you have an economy of scale. And the larger it gets, it's not that much more expensive when there's an economy of scale. On the other hand, if x is more than 1, then that means there's a diseconomy of scale, meaning that it's sort of a really quick increase in price if it gets just a little bit bigger. Now, an illustration of that is if you go to the electronics shop, you can get the 50-inch TV for a relatively inexpensive price. Maybe the 50-inch TV is 2,000 dirhams. But then when you go to the 60-inch TV, 5,000 dirhams. And the 70-inch TV, now that's 10,000 dirhams. Like the price is getting very, very high, a lot quicker, just for a small increase in the diagonal size of the screen. And so that would be an illustration of a diseconomy of scale. And when x equals 1, that means it's a linear illustration. So in the book, the illustration that they give is for a water treatment plant. So let's just look at, in this illustration, what would be the certain variables. So they're saying that in the past, we knew the price of a 0.5 million gallon per day water treatment plant. So MGD, that's just a volume per time measurement. 1 million gallons every day is how much this plant can treat. So to construct that, it cost 1.7 million. And so C1 would be 1.7 million. Q1 is 0.5. And we can write the units, but we don't have to because it's going to cancel out. It's just a factor. And here you can see that it's 2.0 million gallons per day that they want to know the size for, the cost for. And so what you'd use for Q2 is 2 million gallons per day. And then there's a correlating exponent of 0.14. The place that that comes from, here's a table where just in the past they've looked at different pieces of equipment and estimated how much is the exponent, trying to say, is there an economy of scale or a diseconomy of scale? So if you look at these different types of things, look for the smallest exponent. I think maybe is it aerobic digester with the smallest? What that means is that you can build a much larger aerobic digester and it doesn't have very much of an effect on price. That the price is very insensitive to increasing size. But then on the other hand, any one of these factors that has a value greater than 1, and here's this one, 1.35 sludge drying beds. There's something about sludge drying beds that makes it very costly the larger it is. And so those are the factors x that you'd put into the equation. And so if we did these calculations, if we had Q2 is 2, Q1 is 0.5, and we took it to the power of 0.14 and multiplied it by the original known cost, C1, of 1.7 million, then the C2 we would calculate would be 3.55 million. All right, so does everyone have a copy of today's in-class exercise? We're going to start this off with in-class exercise 38, and we're combining two ideas together. The two ideas that we're combining is the idea of an index to track the change in cost over time, along with the cost capacity equation to talk about the difference in size. So we're combining two ideas simultaneously. You can see the equation that I've put here shows how you would combine an index, which tracks changes over time, and this first part of the equation, which is difference in sizes. So in this problem statement, not only are we talking about now a much larger treatment plant, because you can see the components for the future treatment plant that we're going to build in 2017, it's larger. All of those have larger sizes. The aerated lagoon, the blower, the pump, all the components have to be bigger for this new one. And then the other thing that's going to make this new plant more expensive is it's built 7 years later. The first one was built in 2010 when we had an index of 137. This other one was built in 2017 when the index was 164. All right, the table's on the back side of the paper. I'd like you to give this a try and see if you can predict the three components, what's going to be the price of each of them, and then add it up and find the total estimated cost of the treatment plant. Okay, let's have a look at the solution and talk through it a little bit. All right, we'll start with the aerated lagoon. The aerated lagoon in the future is going to be more expensive for two reasons. It's going to be more expensive because it's larger and because the costs of doing things have gone up over time. So that's what we see from the two factors that are included here is the known price in the past was 3.3 million, and then the 5.5 divided by 2 to the 1.13 factor, that's the relationship that tells us how much more expensive this other one will be because it's going to be larger. You can see that the factor works out to 3.13. It's going to be about triple the cost, even though it's only slightly more than double the size. And then the price difference because of the march of inflation, 164 divided by 137, that means it's going to be about 1.2 times increased because of the cost environment. So overall, the aerated lagoon should cost $12 million. I get so sick of this toolbar. $12 million because of the aerated lagoon. If we move down here to the blower and the pump. All right. What does it mean? The blower had an X of 0.46, and so that was an economy of scale compared to the aerated lagoon where it was a diseconomy of scale. Remember, the diseconomy means that you're not getting a discount for making it larger. Actually, you're paying a premium for getting larger, or for having more of something. Usually, you expect, in general, it seems like most of the time there are economies of scale. Like, if you're buying something, you get a bulk discount. You know, if you're going to buy one computer, there's one price, but if you buy 10, the merchant gets excited. Maybe to try and get such a large order, they're going to give you some additional discount. Well, if we add up all the prices, you can see that it should be about $13.5 million in the future by adding the components together. Any questions about the cost capacity equation? So if you think about an exam that might be in your future, that exam is going to have problem-solving questions and it'll also have conceptual questions. What you need to be able to remember and understand about the cost capacity idea is that it's used to predict costs based on differences in size. And it's different from what an index does. The cost index that we were looking at describes the effect of time, inflation over time. So the cost capacity equation, the way you could remember it maybe is, of course, in the equation itself it has this ratio of Q's. And so the ratio of Q is the relationship that explains how different the size of two things are. the cost due to differences in size. Yep. Okay. And this is mostly, for some reason, I'm not sure why, but this is mostly a list of water treatment and wastewater treatment equipment. I would presume that these types of factor relationships, the exponent that you'd need, are available for a lot of different industry as well. And you could create your own exponent. You know, you could fit an equation and do linear regression and find out what exponent should be used based on your own data. All right, the second method we're talking about today is called the factor method. And the factor method is really a pretty useful technique because it allows you to come up with a rough estimate of cost without having to look up every single component that's going to be built or every single item that's going to be purchased. It says that the project in its entirety is a multiplier of some factor, one of the components. And so you can see here in the formula, you'd have the cost of one particular item. C sub E is a cost of major of equipment, and then H is a cost factor that's used as a multiplier to predict the total cost of the project based on just one piece of equipment. So let me give you an illustration of how that would work. I went to a restaurant recently, and when I was just looking through the menu, the first thing I noticed is they were charging 20 dirhams for a bottle of water. That's too high, right? Normally, if you go to a restaurant, the big bottle of water, how much is that? Maybe 3 dirhams, 5 dirhams, right? So in my mind, I said, okay, if they're charging 20 dirhams for the bottle of water, probably I'm going to spend overall 200 dirhams tonight. And it was close. I mean, I think the total bill was something like 211 dirhams. And I just started by using one component and extrapolating from there. So if you say that normally you go to a restaurant and the water is 3 dirhams and you end up spending 30, what you could say is that the multiplier factor for water is approximately 10. And so you could just have an order of magnitude estimate of how much you're going to spend at a restaurant by looking at the price of water. And you don't know what the price of everything else is, but there's somehow a relationship there. The same thing could be true for other components as well. And that's what we're going to look at when we also account for the indirect costs. Now, who can remind us what the definition of indirect costs are? What's direct cost versus indirect cost?
Direct is for what exactly you're paying for.
Okay.
And indirect is like taxes.
It's not taxes.
Like something that has nothing to do with what you're getting. It's like extra costs. Like for example, if they're like people in the restaurant, they're
Yeah.
renting the place.
Okay.
Pay for that. We don't just pay for the food. We
Yeah.
have to pay extra money.
Exactly.
To fund the
All right. Yeah, that's a good illustration. So if you go to a restaurant and you order the mixed grill, in your mind, you're thinking, well, I don't know why the mixed grill costs 38 dirhams, because if I went to the restaurant, I could buy this much meat for 18 dirhams. Well, remember that they have other costs that they have to recover. They have to pay for the cost of the heat, the cooking gas. They have to pay for the tables, the utensils, the servers, the cook. And so there's a lot of things, and some of the things it's easy to say how much of it you need. Like the relationship between cooking gas and a mixed grill, you can say how much cooking gas it takes to make one mixed grill because you know how much heat it is to produce it. But you can't say how many tables are needed for a mixed grill because sometimes it might vary how many customers per day they have using a certain table. And it's a little bit uncertain if you think about the cost of them owning a cash register. And that cash register that they purchased cost money. And so indirect costs are just the things that are difficult to attribute to a specific outcome or a certain economic activity. And so we usually use a factor instead of itemizing them. And so remember I showed you the article headline that was talking about here at the university, they're going to start charging 42% as the indirect cost recovery. That for every every dollar or every dirham in research spending, the university is going to take 42% of that to cover things like utility costs, building costs, the people in the main building, like the accountants who place the orders and set up the payroll and so on. Okay, so what this formula is saying is you can predict the total cost of a project by looking at the cost of one piece of equipment and then adding in additional factors on top of that. And so this one here is just to make sure that the cost of the equipment itself is included. But then the other factors, F sub DC, F means direct cost factors like, for example, if you were going to be constructing a building, you could say, I know that I need 10 million dirhams worth of steel. But then if you're purchasing the steel, maybe that also means that you have to have the laborers to assemble the steel. And so you'd say, for every million dirhams that I spend on steel, I need to have maybe 30% of that for the labor assembling it, and then 10% for utilities, and 5% for permits. And so you add all of these additional factors together, and it allows you to extrapolate the cost of a project based on just knowing one component. And then on top of that, you can see outside of the brackets is where we're accounting for the indirect cost recovery as well. So this is the equation I'd like you to use for part 2 of the in-class exercise.
That is of course like one factor. Why is it summation?
It's one factor. Indirect cost is almost always just one factor. Sometimes an agency would charge a different indirect cost rate for what they call pass-through expenses. And so I had one case, I was doing a research project, and our accountants sometimes were just giving money to a subcontractor. And if all they were doing was just writing a check to the subcontractor, I think they only charged like 10% for doing that. But then all of the money that was going to be spent on campus, where they were going to have to place orders for things or set up payroll, or where the money was being spent in our environment where we had to recover expenses, then they charged 27% there. And so that was a rare instance of two different indirect cost factors, but usually it'll just be one factor. All right, so does everyone have on the back side of the paper, here's the problem statement at the bottom here. A diesel generator. We know that the delivered cost is going to be 975,000 dirhams. We've got some other cost factors related to pouring a concrete pad, operator training, and then we also have the indirect cost. So find the total cost based on those known factors. I think everybody got it. Yeah. It's getting nice and easy, right? It was pretty, well, remember the final is comprehensive, so it includes all that hard stuff from the past. But there will be an emphasis on the newer material, so I'll have more questions on the final exam that are since the second exam.
Will be on Excel, the final?
Probably, yeah, we'll probably be in the computer lab.
70% from the new material and 30% from the old one?
Oh, I wouldn't say percent-wise it'll be like that. I don't know exactly. I haven't written it yet, so I can't say in terms of percentages. Yeah. You get it okay?
Yeah.
All right.
That's what I'm doing.
Good. All right.